Hey guys, the Survives here, and today I'll be talking about the delta y transform, and I'll be going through the derivation as well as the motivation for each step in the derivation. So, um, what is a delta y transform? The delta y transform is basically a way of transforming a network of three resistors like that into another network of three resistors like this, and the values that they turn into is given by these formulas. So yeah, basically that's it. So these formulas are actually they seem complicated, and in fact the derivation is a bit obscure, but I after deriving it and after thinking quite hard at it, I realized that there's there's a series of steps that I made um, that essentially is an observation, and I would like to share the observation with you. So in this video, compared to other videos on the internet and other tutorials they just bring you through the steps. But in this video, I hope to at least help you motivate the the derivation in a way that you can probably remember it better, and if you ever asked to do it by yourself and you have forgotten about how to do it, then hopefully you'll be able to recover the motivation, which is after all the key lesson. The motivation is the thing that motivation behind certain steps is the important thing. So if you ever need to derive it again, you can probably remember it based off the motivation. So yeah, without further ado, let's begin. So we have resistors 1. I'll not write R from now on, just to um avoid the trouble. Maybe I'll write R. So we have 1, 2, 3 like that, and then we assign it values of B, C, and A. Okay, so one thing to note first about the naming convention is that you see A, B, C, right? They come in order, and 1, 2, 3 they come in order as well. So how do you know which way you want to label it? So we see the 1 is like in the diagram is directly opposite A, and 2 is directly opposite B, and 3 is directly opposite C. So that is the usual convention that we do, so that there's no discrepancy in a sense. And from here you can see also from the formulas that the formulas are cyclic, meaning that A here 1, then B here 2, then C here 3. So in this sense, there's 1, then there's BC, which is basically everything that is not A, and there's 2, and then there's AC, and then there's 3, and then there's AB. So they're all cyclic. So as long as you remember one of them, you can sort of remember all of them. So yeah, so before I go on to the full derivation, let me just give you a quick shortcut about the way I remember it. So the way I think of it is this: on this side we have essentially or on the right side we have essentially sum of the products of two terms over one individual term. So it's sort of like sum of 2 over 1, and then on this side we have the R1 is sort of like 2 over sum of 1. So in a sense, that's how I can remember the formulas. But yeah, so yeah, that's just a trick to remember if you want. So okay, so for this, how do you start the derivation? Well, first of all, the thing to remember is that if you have something like that, what's the effective resistance between 2 points? Let's say we consider points 1 and point 3. Then we have essentially we have R1 plus R3. So what's going to happen is that on the left hand side we're going to write the Y, okay, the Y effective resistance, and then on the right hand side we're going to write the delta effective resistance. So both ways of thinking of it. So this one is R1 plus R3, okay, and then on the right hand side both of them must be the same. So we have B in series with A and C. So how does that work? So it's 1 over B plus 1 over A plus C. I'll omit the R over here because the R, B and R, because it's understood. So this can just be written as B times AC, B times A plus C over A plus B plus C. Okay, and then on this side we consider effective resistance between 1 and 2, then we have R1 plus R2 equals to 1 over C plus 1 over A plus B equals to CA plus B over A plus B plus C. And then lastly we have R2 plus R3 equals to 1 over A plus 1 over B plus C, and then equals to A B plus C over A plus B plus C. So yeah, so why do we want to do this? Well, it's the first step in relating these relations are basically the governing equations. So because the whole idea is that the effective resistance must be the same across any 2 points, any 2 of the 3 points. So these equations must hold true. These are the complete equations that basically these are the answers itself. Just that we need to massage it into a form where we can express A in terms of 1 2 3 and the 1 2 each of the 1 2 3 in terms of the A also. So to go over here, so these are the equations. So everything can be known from here. Okay, so everything can be known from these equations. These are the 3 like God equations in a sense. They govern everything. So what remains is then to massage these equations, is to rewrite or massage these 3 equations. So we have 1, we have 2, and we have 3 into 2 things. Number 1, we have R1 in terms of A, B, C, or rather RA, RB, and RC. And number 2, A in terms of R1, R2, and R3. So, and then of course this one R2 also, and the rest are just they are the same thing basically, just cyclically permute the labels. So to do one we realize that to do one is actually really easy, because to do one we just need to take linear combinations of these. So you see on the left hand side we already have linear stuff, so we just need to take 1 plus 2 minus 3. Then that will give us, on the left hand side, that will give us 2R1. Okay, so the reason is because R1 plus R3 plus R1 plus R2 minus R2 plus R3, okay, equals to, then on the right hand side we're going to have the denominator is just common, it's just A plus B plus C, and then the numerator is AB, maybe I should write it in terms of the indices. So it's BA plus BC plus CA plus CB minus AB minus AC. Okay, then this one on left hand side we just get 2R1 equals to, then right hand side a few stuff cancels, so BA maybe BC does not cancel, CA and AC cancels, so we just get 2BC over A plus B plus C. So that we have R1 equals to BC over A plus B plus C. And so we have the answer over here. So yeah, in fact we have correctly derived the ABCs to 1, 2, 3 conversion, which is basically delta to y. We've derived the delta to y conversion, which is these formulas over here. Okay, so we have done that. Now what remains is that so of course the others will just be R2 equals to AC over A plus B plus C, and lastly R3 equals to AB over A plus B plus C. So these are just the rest of them in an exact similar fashion. So for example, they just involve different combinations. So the second one is going to be 2 plus 3 minus 1, and the last one is going to be um, last one is going to be 1 plus 3 minus 2. So yeah, okay, so now we have done that. um, that was simple because we already have these linear factors. They really linearly add up, right? So that seems easy. But the tricky part is the second part. So how I am gonna motivate how we're gonna do it. So um yeah. So the first thing we observe is that we have essentially these three items, right? So how do we do part two? So we do part two. We essentially um so okay, so we have B, C, A, C, and A, B. So if you realize that if we let's say we want to isolate one of them, okay? So let's say we want to isolate A equals to something. So A equals to something, but we only have these three relations. So how do we use these three relations? Well, if you realize that AB, okay, let's say we have AB, okay, and let's say we have AC, then we multiply these two, then we're gonna get A squared BC. Then if we divide both sides by BC, then we're gonna get A squared. So we see that we sort of isolate it a little bit. Okay, so with these three factors on top, we can sort of isolate it, but it's not really the complete picture either, because we don't have these three factors directly. We have R1, R2, and R3. So if we briefly translate this, let's consider the possibility of R3 times R2 over R1. Okay, and what is that going to be? That is going to be AB over A plus B plus C, then that's multiplied by AC over A plus B plus C over BC over A plus B plus C equals to A squared over, and then we see the denominators, they sort of appear in an annoying way, because the denominators they now they don't allow A to be alone. You see if the denominators were gone, right, then we just got our answer. Then we have expressed A in terms of R1, 2, 3, but this denominator is here, so it's a bit annoying, but it's alright, okay, because we realize that so what is so we have A squared over A plus B plus C, as well as stuff like AB over A plus B plus C, okay, and we also have AC over A plus B plus C. So the key is that if you realize that if you want to find A alone, okay, and we only have, in the numerator we only have product of two factors, then what we can actually do is we can actually, to cancel a denominator, we can multiply the upper and lower by A plus B plus C, then A plus B plus C, and then what is this? You realize that this is actually exactly the first three terms here added up. So that's precisely what it is. So essentially, when you add up these three, you just get A. So isn't that amazing? By consider like products of two stuff, and then considering the A squared, right, we have A, we've isolated A. So what this remains is just to bring in the 1, 2, 3s. So the first guy over here, we have already calculated it to be this, right? And then the second guy, so the first guy is just R3 R2 over R1. Then the second guy over here is just this guy, so that's plus R3, and then the last guy is just this guy, so that's this guy, so that's plus R2. And what do we get on the right hand side? We just get R3 R2 plus R1 R3 plus R2 R1 over R1. So So that's our answer. A is equals to that, and and that and in fact we check up here, it agrees with this formula over here. So um, yeah, that's exactly how to do it. So I guess the key observation over here is that if right we only have, if we want to isolate A, okay, and we only happen to have products of two terms, for example AC or BC in the numerator, and then we only have these products of two terms in the numerator, and then we have this annoying denominator here, then in order to isolate A, we can multiply the, we can put the we can slap the denominator in place, and then just multiply the same thing in the numerator. Okay, so most of them are fine because we have AB and AC already, so AB and AC is fine. But AA, we don't really have AA, so how do we find AA? We use we use divisions of these. So we use this clever product and division to get A squared. So yeah, that's basically a short derivation of the delta y transform with a bit of narration and motivation involved. So I hope that this makes it clearer to you how you can derive it, and actually it's not that scary after all. So the steps, in summary, the steps that we took first was we drew the diagram, okay, then we calculated the effective resistance between any pair of points in these 3 points. So there's 3 choose 2 is equal to 3, so there's 3 equations, and then we want to write the 1 2 3s in terms of ABCs, which is easy because we already have it linearly added here. And then next thing we want to do is we want to write the ABCs in terms of the 1 2 3s, and that is a bit harder, but after obtaining the first result, we just needed to we just needed to make this single observation to get A squared over A plus B plus C, and then after that we just do this. So those are the overview, and I hope you have enjoyed this video. If you did, please leave a like and subscribe. Yeah, have a nice day. Bye.